What's up, man?
Hey, what's going on? Thank goodness you're here. I'm so lost.
What are you working on?
Nuclear physics. This is nothing I'm used to. What happened to F equals ma?
With enough studying, this could be as easy as Newton's laws.
I doubt it.
Well, what are you struggling with?
Everything.
Well, maybe we should start with the basics.
Physicists have constantly sought to find the most fundamental building blocks of nature. They thought they found it with the elements composed of atoms. In fact, the word atom comes from the Greek atomos, meaning not divisible. The atomic theory provided an accurate description of chemical processes. As new evidence came out, he found that this wasn't the full picture. J.J. Thomson found that electrons were electrically negative and came from ordinary matter. In order for this to be possible, there needed to be positive charges somewhere. Thomson proposed the plum pudding model, where electrons were mixed with smeared-out positive charges. Rutherford performed an experiment to find out how the atom was structured. By shooting positively charged helium nuclei at a thin piece of gold foil, a new insight into the structure of the atom was discovered. Most particles behaved as expected with the plum pudding model, hardly scattering at all. However, there were particles that deflected back at angles over 90 degrees. Rutherford's experiment led to the model of the atom with a small positive nucleus at the center of orbiting electrons. Today, we know that the nucleus is made up of positive protons and neutral neutrons. These particles have the same spin and almost identical masses, though neutrons are slightly heavier. Both particles are referred to as nucleons. The most simple nucleus is that of hydrogen, composed of one proton, while the largest nucleus has nearly 300 nucleons. The atomic number of an atom is determined by the number of protons in its nucleus. For instance, carbon has an atomic number of 6, because it has 6 protons. Atomic mass is found from the number of protons and the number of neutrons in the nucleus. Every nucleus has a binding energy that holds the nucleons together. Some configurations of nuclei are stable, while others are unstable. Those that are unstable are radioactive and decay to find more stable configurations.
So let me get this straight. Atoms describe the chemical process, but they aren't the whole picture in themselves? Atoms are composed of, positive nuclei orbited by negative electrons?
That's right.
So, these nuclei are made up of two kinds of nucleons, positive protons and neutral neutrons, and using these nucleons, we can learn different things about the nucleus?
Exactly.
Does this have anything to do with that worm chart?
You mean the chart of the nuclides? Absolutely. Look at it next time.
You know, this nuclear stuff isn't so bad.